Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material. The structure drawn shows a conjugated diene, specifically hexa 2,4-diene, CH3, CH is equal to CH, CH is equal to CH, CH3, which has two internal double bonds in conjugation. Moving on to the next step. Reaction with two equivalents of Br2 in CCl4 is an electrophilic addition, anti-addition, across both double bonds. Each Br2 adds in an anti-trans fashion across each double bond. Moving on to the next step. Identify the stereocenters formed. Addition of Br2 across both double bonds of hexa 2,4-diene generates 4 stereocenters, C2, C3, C4 and C5, each bearing a Br and H or methyl at the ends. Actually, the product is 2, 3, 4, 5 tetrabromohexane with stereocenters at C2, C3, C4 and C5. And for the final step, analyze the stereochemical outcomes. Because of anti-addition to each double bond and the symmetry of the molecule, it is a symmetric molecule, CH3 groups at both ends, we consider. Anti-addition to the C2 is equal to C3 double bond gives one relative configuration at C2 and C3. Anti-addition to the C4 is equal to C5 double bond gives one relative configuration at C4 and C5. The molecule has a plane of symmetry, C2 symmetry, so some combinations of products are identical or meso. Enumerate the stereoisomers. For 2, 3, 4, 5 tetrabromohexane, a symmetric molecule, the possible stereoisomers from anti-addition are 1, 2R, 3S, 4R, 5S, anti-addition to both double bonds. This is a meso compound due to internal symmetry. 2, 2R, 3S, 4S, 5R, another combination. Given the molecular symmetry, this may also be meso or identical to above. 3, 2R, 3R, 4S, 5S, or 2S, 3S, 4R, 4R, a pair of enantiomers, 1 DL pair. This gives 3 stereoisomeric tetrabromides, 2 meso compounds, or 1 meso and 1 DL pair counting as 2 stereoisomers plus 1 more, totaling 3 distinct stereoisomers. Why not other answers? Option A, 2 undercounts, it misses 1 stereoisomeric form. Option C, 4 and D, 6 overcount because molecular symmetry reduces the number of distinct stereoisomers. Some would be identical due to the symmetric nature of the molecule. Therefore, the correct answer is B. Therefore, the correct answer is option B.